Hi everybody, RH here. We're going to talk a little bit more about differential equations. And what I'm going to do is just extend the ideas that we discussed in the first video having to do with what differential equations actually are. What I want to do is provide a solution for one of the basic differential equations, just to talk about the pieces and how we put things together when we're solving these specific types of problems. You recall from last time we were talking about the temperature of coffee in a cup. And what we decided was that we were going to start with the temperature as a function of time. So this is temperature, and our independent variable t is time. And then we have k, which is a proportionality constant that is associated with our model. And we derived last time that the rate of change, we don't know what the temperature is. The whole point of differential equations is to solve for functions. So we are trying to find the function that is represented for the coffee, and of course it is a function of time. As time changes, the temperature is going to change. So we have the rate of change of temperature with respect to time. This piece we do know. This is negative k times the difference between the current temperature of the cup of coffee and the surrounding temperature. And what we're going to do is we're going to start with the surrounding temperature is 72 degrees. That's an important piece of information. And we actually have one more piece of information, which is that the initial temperature of the coffee is 172 degrees. And of course, we're talking degrees Fahrenheit. Let's rewrite it. We have the rate of change of temperature with respect to time is equal to negative k, and then we have a t minus 72. And what we want to do is, if we have a rate of change from calculus class, what do you think of? You think about finding the antiderivative. You think about integrating. And that's exactly what we're going to do in this particular situation. So we're going to come up here and we're going to divide by t minus 72, and then we have the rate of change of temperature with respect to time is equal to minus k. Now it turns out we can integrate both sides of this equation with respect to time. So we're going to integrate 1 over t minus 72 with respect to t, and we'll have a negative integral k with respect to t. And this piece here has to do with the chain rule. I'm not going to provide the detailed explanation for that. I'm happy to do that if you want to sit down and have that conversation. Right now what I'm going to do is just say, hey, the solution here is the natural log of the absolute value of t minus 72 plus some constant of integration is equal to negative k times t. Remember, k is a constant plus a different constant of integration. And now it's an algebra problem to solve for the capital T. Remember, we're solving for function temperature. So we can certainly combine the constants together. We would have a natural log t minus 72 is equal to a negative kt plus c3, where c3 is just c2 minus c1. We don't need to keep track of the intermediate constants. We're only interested in that one at the very end. And then at this point, we're going to exponentiate both sides of the equation. And when we do that, we have an e with a natural log of t minus 72 is equal to, and we're going to exponentiate a negative kt plus c3. In this particular situation, we have to determine whether t minus 72 is going to be a positive or negative value. Well, we know that our coffee is starting at 172 degrees, and so we're going to have a positive value inside of this absolute value piece right here. So that's going to give us t minus 72 is equal to, we're going to do a little bit of algebra over here. We have an EC3 times an e to the minus kt. And now we're almost there. We have our function, which is temperature as a function of time, is equal to, we're going to do a little bit of a simplification. E raised to a constant is just another constant. So we're going to replace the e to the c3 with just another constant. And then we have an e to the minus kt plus 72. And this is our general solution. What we're going to do at this point is apply the information we have, which is the initial condition. So let me swing our solution back over here, and we have c e to the minus kt plus 72, and we're just going to apply this information. So t evaluated at time 0 is 172 is equal to c to the 0 plus 72. And of course we know e to the 0 is just 1, and what that's going to give us then is c is equal to 172 minus 72, which is 100. And now we can include that piece of information, and we're going to have our final answer here, which is, let me scroll down just a little bit. We have what we call a specific solution, 100 e to the minus kt plus 72. This is our specific solution. What do you notice? We're still missing the k value. The k value comes from algebra and knowing a little bit more information. We have to have an additional data point to solve for k. So it turns out that when time is 21 minutes in, that the temperature at time 21 is 119 degrees Fahrenheit. We could use that piece of information to solve for the k. Let me show you that briefly, and then we'll be done with this problem. we will have created the function which represents the temperature of the cup of coffee. So T at time 21 is equal to 119, and that's equal to 100 e to the minus k times 21 plus 72. And now you can see this is just an algebra problem. We're going to subtract the 72 off of both sides. We have 119 minus 72. We're going to divide by 100. That's equal to e to the minus k times 21. Then we can apply the logarithm to both sides in order to solve. So let me continue over here. We'll apply natural log to 119 minus 72 divided by 100 is equal to, and the natural log of the exponentiation is negative k times 21. And now we just divide. 1 over 21, natural log 119 minus 72 divided by 100, and that's equal to negative k. And actually I should take the negative and just keep it with the 21, and so we can just calculate the k directly. One last step then, what we're going to do is I'm going to just open MATLAB, and listen, we can do these things in MATLAB, Python, Excel, calculators, however, it doesn't matter. So we have the log function, log is the natural logarithm, and we have a 119 minus 72 divided by 100, and then we're going to multiply that times a 1 divided by negative 21, and that's going to give us our k value. So we have 0.36, it's 0.036 is equal to k. And our final answer is 100 e to the minus 0.036 t plus 72. And that's our final specific solution with the k value calculated. Listen, if you need any help, if I can help you understand things, if I can help you calculate, just let me know. I'm happy to help out. Thanks.